Hey, good morning. Welcome to the show. I think I'm gonna start doing these live streams to just cover some kind of news that pops up, and I think it'd be a good opportunity to cover kind of a range of things. So I kind of want to work like macro to down to the coding tip level, and just cover what's going on or what I've been looking into recently. So yeah, a little background about me. I've done web programming for a long time. Done a lot of, started out doing a lot of like Perl, PHP. Obviously, more recently, have done a lot of JavaScript programming and like React and plain JavaScript and Angular. And then I've also done a lot of Ruby and Rails programming. And then also have an interest in game programming, so I've done a bunch of stuff in C Sharp. But most of my experience is pretty much working as like a web app software engineer. And so the reason I mention that is because it's a very popular area to work in, but there's also lots of different types of programming that you can do. And the way that you look at things depends a lot on what you're kind of optimizing for. So we'll get into a different type of programming and some interesting ideas about what to optimize for there and how people in that world look at the web programming world pretty critically. So I've been trying been trying to open myself up more to kind of their view on things. And I think there's an opportunity for me to kind of grow and learn a lot from them. So yeah, let's just get into it here. So the first thing I wanted to look at is a lot of the big FANG or Mongo, whatever you want to call it now, the big tech companies just reported earnings. So I think it's pretty interesting to go through what's happened just in the last few days. So Apple had a pretty good earnings report, and you can see that their stock over the course of the last year is still on a pretty good trajectory. I'm just going to kind of quickly go through the different ones here. Facebook did not have a good earnings report. They missed by quite a bit. I think they expected was somewhere in the teens, and they had like 7%. And there were a few big factors that contributed to that. So one of them was just the new privacy rules have really hurt them. I think it's going to cost them something like $10 billion in revenue, ad revenue. So, the restrictions around privacy are really starting to hurt them because, like, fundamentally, they're basically a business for the way they make their money, I should say, is through selling ads for the most part. And I think for the first time ever, they saw a contraction in their daily active users, which is not a good sign. It's important to remember, too, that Meta is more than Facebook. It's, Facebook, Instagram, WhatsApp. So I think there's some pretty big generational divides on these social platforms and tools. But yeah, so for the first time, it looked like Facebook had some decline in their daily active users, which is not a good sign. And then the other big one is they're making this push into the metaverse. I don't know what to make of that. In some ways, I think it's pretty silly. We've seen VR pushes in the past that really kind of fell flat on their face. If you're old enough to remember, there was this big push for this thing called Second Life, where you were going to kind of have a fake avatar in virtual reality and everybody was going to be online. And that ended up, there was a lot of buzz around that whole idea in the early 2000s or mid 2000s, and it really just kind of flopped. And then not that long ago, we saw kind of Google's push into AR and with the Google glasses. And again, there were, a lot of privacy concerns and just general skepticism about that. And I don't know what actually killed it off, but it just kind of seemed to fade away into the background slowly. I personally think what the technology that Facebook has or that Meta has is really impressive. And they have John Carmack, who's like no slouch, working on a lot of the technology, at least for like the Oculus Rift and some of its applications. And I think that's really cool. And I could see a lot of really good practical applications for that. Like any of the AR stuff is super useful, especially for certain professions. Like if if you think about professions where you need to see you need information quickly on what's around you. So that could be like law enforcement or military or really anything like tourism. You could set up like AR glasses for going through museums to give you information based off of what you're looking at. I just think there's like a ton of applications for it. The part that I don't get is the metaverse, like this like virtual reality world that we're going to be connected to. It just seems I don't know. It doesn't seem very exciting to me, and it seems like it's just kind of a gold rush to sell these worthless items. But maybe I'm just maybe I'm too dumb to understand it. I don't know. So anyway, that's what's going on with Meta. They dropped. They got just crushed. Their stock price dropped like 25% after hours earlier this week. And you can see they're still kind of struggling if we zoom in on this a little bit. I mean, it just fell off a cliff overnight. It went from 323 down to 230 or 240, basically. So, I mean, I think on the whole, Facebook's got a really strong core business. And a lot of the reason their earnings were down was because they were investing in this whole metaverse idea. I do think it's worrying that their usage is dropping. I think that's probably the worst thing that they have going for them. But personally, I saw this as a nice buying opportunity. So I'm not suggesting you buy it. It just personally, that's what I did. And some of these, you'll see as we go through these, a lot of these have dropped a lot. And it's just a good time to stop and consider if it is a buying opportunity. I'm not going to tell you how to do that, but it's always a good thing to look at. So, for example, with Meta, they had worked their way up to a high of like 370 or 380 almost, and now they're down to 235. That's quite a drop. It's like a third, drop by a third basically. And yeah, basically they're at a level below a year ago at this point. Looks like you have to go back to June or July of 2020. Wow, that's pretty rough. So another interesting one is PayPal. So PayPal, I think I don't think they did terribly, but I think they missed earnings, and I think there's a lot of worries that they're facing increased competition from a lot of these other ways of paying for things online or like point of sale systems. So if you think about like Square or paying for things with cryptos kind of getting increasingly popular. But just that space in general is getting a lot more competitive. And PayPal is definitely one of the biggest players out there, and they have Venmo, and they're just kind of like entrenched because they've been around. They were like the original kind of online payment system. So I don't see them going anywhere. I don't see them, I don't see them going to zero. I think they're definitely going to have more competition. But this is another one of these companies where if you look at their recent highs, they're up in the 300s, and now they've dropped all the way down to 125. So, it's dropped, what is that, 60-70%, something like that. So this is another company where if you're interested in it, it's potentially a buying opportunity, but I'll leave it up to you to evaluate, whether that makes sense for you or not when you're interested. Another reason this is important is if you're going to go work for a large tech company, generally what's going to happen is your compensation's going to be salary, and then at some level, I don't know what it is these days, but at some level when you get into like around like 150 or 200 K for salary, if you have any other compensation, it's probably going to be in stock. I think like RSUs for publicly traded companies. So what this means is, you may be getting half of your compensation in salary and then half of your compensation in stock, or like 2/3 in salary and 1/3 in stock. So for these big companies, if a big part of your compensation is going to be stock, it's really important to follow like what you think is going to be happening with the company and if they're making what you think are good moves. And I know the FANGs have kind of driven the market up in this big bull run cycle that we've had, or this big bull run that we've had. So it's been kind of safe to assume they're going to keep going up, but I don't know if that's necessarily a safe assumption moving forward. So just something to consider if you're, shooting for working for one of these giant tech companies. And then we'll take a look at Amazon. So just quickly, so Amazon was like, after Facebook got hit so hard with that 25% drop overnight, before earnings were reported for Amazon end of day yesterday, there were a lot of fears that it could drop as well. And the stock dipped quite a bit, and it got all the way down to like about 27.75. And then, they had their earnings call at the end of the day yesterday, and basically they just crushed expectations. So the stock has just jumped back up kind of to be at the level it was before the worry set in. I'm actually sad I missed this one. I almost ordered some Amazon stock yesterday morning and backed off. So anyway, just something to consider. They're up almost 15%. They've been bouncing around between like 13 and 16% since that report. Yeah, I think that's kind of the stock tech industry related news that I was wanting to go through. I'm going to close some of these out here, and we'll get on to something else. So the next place I wanted to go was taking a look at this thing that I mentioned at the beginning of the stream, which is, there's different types of programming you want to use based on what you're doing, what kind of products you're working on. And one thing that I've always been really interested in is game programming and game development. And there's a couple of reasons for it. One is that I've always just been really into games. You probably can't see it with the way the video is cropped here, but I've been really into games since I was a little kid, starting as far back as like the Atari 2600. But was, got really into the Nintendo and the Super Nintendo, and then have just kind of stuck with gaming throughout my life, and still play games occasionally. I just streamed some Celeste last night. So yeah, it's kind of been a hobby of mine for my whole life. But another thing that I find really interesting is it's such a different mindset that you have to get into when you're programming for games, because you really want to get the most performance you can out of your machine, especially if you're going to be doing 3D games, anything that's I would say AAA games, but really if you're doing any kind of game, you just kind of want to get the most performance out, because the more efficient you can be, the more things you can throw into the game. Like if you want to have more animation going on, or if you want to have especially in 3D games, like if you want to have more detail, or like a further distance out that you can see where things are a high level of detail, or if you want to add things like lighting or volumetric lighting or particle effects, or there's just kind of like, you're always resource constrained in video games unless you're making like a pixel art style game. There's cases where you're less restrained, but you still do kind of want to get the most out of the hardware that you can. And it leads to a few different things happening. And the reason I have this talk up here is there's a couple of people who I've been following recently who are really good video game programmers who have been putting out more and more videos. So if you're familiar with Braid or The Witness, that was created by Jonathan Blow. That's not this guy. This guy is Casey Muratori, and but they work together. And I think they've both been in the games industry for 30 years, 25, 30 years, something like that. But he does a lot of very good videos for people I'll say, like, for me personally, just caring mostly about, writing Ruby and JavaScript in these higher level, generally like interpreted languages. He has a lot of really interesting talks about doing things at a lower level, doing things more efficiently, and questioning some of like the accepted wisdom on how to organize code, or what's like considered a good program and what's not. I think in web programming, because it's done in these big teams and it lives for a long time, like the software can live for 5, 10, 15, 20 years pretty easily. The focus that most people have there is making it easy to maintain, and kind of the general accepted wisdom on that is this idea of like solid, and these solid principles can guide how you organize your code and make it easy to add to over time or to modify or whatever. But the point that he makes is, none of the stuff actually has anything to do with anything real. This is all conceptual, and it's really focused on how you're organizing code and not necessarily on how you like write performant code or it doesn't relate directly to like the hardware in any way. It's very much just conceptual and in some ways kind of academic. And I think one of the problems that he has with it is there's also not really a great way to measure this kind of scientifically to say whether a program that conforms to all of this is actually better or worse. So he's, I think, just generally kind of frustrated with accepting that this is true when there's not really any like data or studies or anything to show that this actually is better. I could say like personally from working in a lot of code bases and large code bases and older code bases that just from like the standpoint of managing code and being able to make changes easily, the code that conforms to this is usually easier to change and to test, and there's definitely benefits to it. But I could definitely see his point about like why have we just accepted this as gospel. So anyway, if you're interested in learning more about that, this is a really good video. I'll put a link to it in the notes for this stream. But yeah, he's basically saying, where does bad code come from? And he kind of just goes through where, why he thinks bad codes come about. And I think his definition is largely like revolving around the fact that because he's focused on the hardware, the modern computers and CPUs are just so insanely powerful, especially compared to like, 20, 30, 40 years ago, that there's not really an excuse for anything to be slow that you're interacting with on a computer. And so he's kind of looking at it from the standpoint of like, why is everything that we use so insanely slow and laggy and like bug prone? And yeah, so that's kind of the perspective he's coming from. So anyway, if you're interested in that, I highly recommend checking out any of his videos. Jonathan Blow has a lot of good videos on it, but his are a little less, well, I shouldn't say that. He has a lot of streams he's done on the topic. I don't know if he necessarily has any talks that he's done that are more kind of like focused, but he may have a couple. I'll have to look for those. Maybe I can share those in the future. And then another video of Casey's that's kind of in the same vein is like talking through what simple code is from the perspective of somebody who really cares about the hardware, and then being able to write code that is maintainable but takes advantage of the hardware to its fullest. So he goes through this trade-off between simple code and high performance. And this one's more of a conceptual exercise, but he just walks through like he basically starts from like what's possible, like from first principles, like what should a modern computer and GPU and CPU be able to handle, and then contrast that with like why are things slow, and then he kind of steps through like how he would make the most of the hardware, or what basically like what's possible, like what you should be able to do in terms of performance versus like what's actually happening. And I'm not sure if it's this video. I'm going to have to dig through a bit more, but he actually has an example he walks through for an algorithm that he improved for the witness that was part of the tools that the level designers used, and how he was able to take it, just with some pretty small changes, he was able to take it from being something that you had to use and then wait for like seconds, maybe even like as long as 5-10 seconds for feedback, and then see what happens and then do your next change. And the video focused a lot on how to go from a situation where you you have these long cycles where you try something and then you just sit there and then you wait and then it does whatever it's going to do and then you try it again, where it keeps you from being able to, like, as a creative person or just somebody wanting to work on things, it keeps you from being able to try a lot of things because you just have these long cycles. So in the vein of efficiency, he talks a lot about, like, how do you take things from this situation where you have this huge lag between what you want to do and what the computer can do to a point where it's real time, or effectively, it seems real time or near real time. So he goes through how he did that with the system that they used to design levels on the Witness, and how just with a few small changes, I think in like a day, he was able to get it to go from that situation where it was like these really long cycles of 5 and 10 seconds, or I think even 30 seconds in some cases, down to being a pretty much real time. And so it was just a really interesting talk to go through. Some of it had to do with frameworks and trying to reuse code that worked for very generalized cases, and instead replacing that with something that was extremely focused on just his case. And that did a couple really interesting things. One was the code was just purely tailored to what he was doing. He was able to not care about 4 or 5 major concepts that were in the general case. And then also just in terms of debugging, the stack trace, went from something where you had to go through 30, 40 layers of code in a framework to just within his program that he wrote. So there wasn't all this conceptual overhead too, with like jumping around the code base to different places in the stack trace. So yeah, any of his videos, if you're curious about that kind of stuff, I think are very interesting. And I'm probably going to go into more depth on some of these in the future. But yeah, I'm trying to force myself to start spending some time at least thinking about programming from like the perspective of somebody who would be working on something like, say, a game where they're really focused on getting the most out of the hardware and like really getting rid of as much complexity as they can, because it's any complexity you get rid of is just going to give you more performance. So yeah, I found that to be really fun. And then yeah, finally here I'm going to just jump into so the thing I want to look at here is a common way I see code written, and just a suggested thing to try to improve it. Sorry, just a second. Trying to make sure this is showing up on the stream. Yeah, I'm not sure. Okay, well anyway. So yeah, basically here, so this is something, so here's a tip for a problem that I see a lot with programming. It's not necessarily that you always want to do this, but you should at least know that this kind of approach is there, because it may make sense for your situation. But recently I was looking at a post on Facebook where somebody was asking about some code that they'd written, and they had a lot of methods that looked like this. So what was going on is, they had some kind of array with objects, and then what they were trying to get to was they were trying to filter out the objects to just be ones of a certain type, essentially. So in this example, you can see we have like products, these objects in here. It's just like an array of objects that represent an order, and the order is whatever the product was, and then like whatever the quantity is for it. And you can see we have a mix. So we have like apple, pear, apple. And what this person was trying to do is they were just trying to get the apple orders, essentially. And the way they were going about doing it was actually more complex than this. But I'm just going to show you kind of a cleaned up version of it. So what they were doing was they had something that was for getting like all of the apple orders. So it took the orders and then used a for loop to go through all of the objects in the array, and then based off the type, just did a check to see if it was the type that they were interested in, which is apple in this case, and then pushed it onto the values that they wanted, and then just eventually return the values. And then so down here I'm actually gonna set up my orders by by calling Apple orders with all the orders, and they're just outputting those to the browser. So you can see over here, we have two objects or two orders, and they're both orders of apples. So there's a couple things in here that kind of stand out to me as being a little weird. One is that we're using a for loop here, and then within the for loop we're checking for a type, and in one case we do something, and in the other case we just don't do anything. And it just seems like a little bit of an odd use for a for loop to me. And then the other is just that there's this concept of checking like a type or by type, but it's just kind of implied. It's not really set up as like a concept in the program. It's just like, hey, I happen to care about products named Apple. And yeah, so there's a couple things about that just seemed a little off to me. So one way that I would go about trying to clean this up, I'm just going to pull up some code here, is, let's see, so I'm going to replace this stuff. So another way you could go about doing this is you could set up something that checks if an order is of a certain type. And what this is going to do is you're going to give it a type, and it's going to return a function that takes an order and checks its product to see if it's of that type. So now you have this concept in the code itself that is a check to say is order of type, and you can change the type. Which is nice because you might, if you care about Apple orders, you probably eventually are going to care about pear orders or orange orders or whatever, whatever the type is that you care about. And then the other thing is conceptually what's happening in this for loop is really filtering. It's going through and filtering all of the orders down to the ones that are just for Apple products and ignoring the other ones. And then there's built-in tools in the language to accomplish that. And really in most languages you'll have the idea of filtering and mapping and stuff like that. So here I'm just making another function that takes orders and a type, and in this case it's going to be it's just going to default to Apple because that's the only case we care about so far. And it's going to take the orders, it's going to filter them, and the thing it's going to filter by is it's going to say is order of type, and then whatever the type is. So in this case it's going to be Apple. So it's saying, it reads a little better. It's saying, basically filter orders by whether it's an Apple order or not. And then once you do that, you can just say my orders equal orders of type for orders, and it's implied because this is a default value for the argument that these are Apple orders. But if you wanted to, you could just pass in Apple as well. And if you were using something like TypeScript, you might want to make like an enum for your order types so that you could actually, or sorry, for your product types, so that you could only allow filtering by like valid product types. But when you do this, you end up with this thing, which is pretty reusable. You can get a is order of type check for any kind of type. You could actually do the work of getting orders of type. And one thing that I like too is I generally like to keep my functions pretty concise, and this is going to be about as concise as it gets because you just want to return this, so you don't need like the curly brace wrappers around the function. So you can just use the arrow and return the result of this implicitly. And yeah, it just makes it a little bit shorter and easier to read. I'm going to actually just get rid of this for now just so we can see how short it actually is. And then you just, you have actual concepts in the code for all the different conceptual things that you're doing that kind of you can reason about, independently, and then they're basically just used right here. So yeah, I mean, I'm not saying this is what you want to do for every time you run into this kind of thing, but generally if I see a for loop where the only thing that's happening in it is an if statement that conditionally does something, it's probably an opportunity for using something like filter or maybe something like map if you need to transform. If you have an array and you want to like transform certain elements, you might want to do like a filter and then a map, or you might want to do like a map and then a like compact to get rid of empty values. But there's a lot of common tools that are just built into languages to do things like this that you should take advantage of if you can. Like filter and map are really good ones. Filter, map, reduce, compact, those are good things to understand, because you can really do a lot of code cleanup with them, and they're meant for patterns that get that are going to pop up all over the place. So anyway, that's just my quick explanation of how you might go about cleaning that up. But yeah, thanks for watching this. I'm gonna try to do some other. I'm gonna try and do these, I think, regularly. I'll kind of have to see, but yeah. Anyway, thanks for watching along, and I'll see you in the next one.